Hello friends, welcome to the channel. This video contains detailed solution for questions on electromagnetic theory and thermodynamics appeared in Assistant Professor Recruitment exam March 2022. Question is, in figure XY is an infinite line charge distribution. P and Q are points as shown. The ratio of the electric fields at P and Q is given that XY is infinite line charge distribution and P and Q are points at a distance a from XY. Then electric fields at P and Q is given by E is equal to lambda divided by 2 pi epsilon naught A, where lambda is linear charge density and A is distance from XY. Here P and Q both are at same distance from XY, that is A is same, therefore ratio of electric fields at P and Q is 1:1. The electric flux passing through a hemispherical surface of a radius r placed in an electric field E as shown is. So here we have to calculate electric flux through a hemispherical surface. Since it is hemispherical, so we can consider this base as a circle of radius r. Then electric flux phi is given by contour integral E dot ds, that is E, since it is E dot ds, E into ds into cos theta. If you simplify this integral, you will get the value E into pi r square. Therefore, option A is correct. The electric field of a wave propagating in the xy plane with wave vector k making an angle of 30 degree with the x-axis is. So here given that, consider this xy, wave is propagating in xy plane. So that means wave is propagating in a xy plane with the wave vector k making an angle 30 degree with x-axis. Then the electric field expression can be given by E is equal to E naught cos omega t minus k dot r. So here it is E naught cos omega t minus, so expanding this, kx cos theta x minus ky cos theta y minus kz cos theta z, where theta is the angle made by wave vector with x-axis and theta y is the angle made by wave vector with y, similarly theta z. So here theta z is 90 degree, therefore cos theta vanishes. So value of this will be 0. This term will be 0. Then E naught cos omega t minus kx, this angle is 30 degree. If it is 30, then angle made by k with y is 60 degree. Then substituting the values, cos 30 is root 3 by 2, cos 60 is 1 by 2 into ky. Therefore, option B is correct. The magnetic field due to a long straight current carrying conductor of radius r when r is greater than capital R. R is the distance between the point and the axis of the wire is proportional to, here magnetic field is from standard formula, magnetic field is given by B is equal to mu naught divided by 4 pi 2 I by R, where I is the current and R is the distance between the point and the axis of the wire. Therefore, magnetic field is proportional to r raised to minus 1. A charge q is located at the center of hypothetical cube. The electric flux through any face of the cube is given by. So here consider a cube. Here charge q is placed at the center of cube. Then the electric flux through the cube is given by phi is equal to q by epsilon naught. So here we have to calculate electric flux through any face of the cube. Since cube is made up of 6 faces, phi phase is given by 1 upon 6 q by epsilon naught. Therefore, option D is correct. When a voltage standing wave ratio VSWR in a transmission line is 3, the magnitude of reflection coefficient will be. Reflection coefficient R is given by VSWR minus 1 divided by VSWR plus 1, that is 3 minus 1, 3 plus 1, it is equal to 2 by 4. Value is 1 by 2. Option C is correct. A plane electromagnetic wave traveling along positive z direction has its electric field given by Ex is equal to 2 cos t, Ey is equal to 2 cos 90 plus t. The wave is, so given that this is x, this one is y, this is z, electromagnetic wave is traveling along positive z direction. Then Ex is 2 cos t, Ey is 2 cos 90 plus t. That means Ey leads Ex by 90 degree. Therefore, since rotation is from right to left, it is left circularly polarized. Option C is correct. When a negative charge is placed at the center of the sphere, the direction of electric field on the Gaussian surface is. So here you know that when charge is positive, the electric lines are always moving away from that charge, and if it is negative, then it is always inwards. Therefore, when it is negative charge, it is radially inward. Option B is correct. The electric field inside a conducting material of radius r. So, for any conducting material, electric field inside it is always 0. Therefore, option B is correct. The displacement current arises due to, this direct question, we know that displacement current is always due to time varying electric field. The power radiated by an oscillating electric dipole is proportional to the frequency omega by omega raised to 4. The potential which exhibits the dependence of the potentials on the velocity of the charged particle is known as Leonard-Wishart potential. The first law of thermodynamics stands for conservation of, direct question, it stands for conservation of energy. Given for solar radiation, lambda m, that is maximum wavelength, is equal to 4753 angstrom, and Wien's constant B is equal to 2.898 into 10 raised to minus 3 meter Kelvin. Then the surface temperature of sun is. So from Wien's displacement law, lambda m into temperature T is always a constant. That constant is called as Wien's constant. Then T is equal to B divided by lambda m. If you substitute the values of B and lambda m, you will get the answer 6097 Kelvin. Therefore, option B is correct. A second order phase transition is characterized by a, so options are latent heat, discontinuous change in specific heat, change in volume, irreversible behavior during warming and cooling. So for second order phase transition, always we find discontinuous change in specific heat. In a grand canonical ensemble, the comprising systems are always capable of exchanging. So we know that for canonical ensemble only energy can be exchangeable. Then for microcanonical, no exchange of energy and particles. In a grand canonical ensemble, it is capable of exchanging both energy as well as particles. The partition function of two base particles, each of which can occupy any of the two energy levels 0 and E is, or epsilon is. So here there are two energy levels of energy is 0 and epsilon. We have to calculate partition function of two base particles. So it is wrong. It should be Bose particles. From Bose-Einstein statistics, so if it is Bose particles, it can occupy in same energy levels or like this. So here total energy will be 0. For this one it is 2 epsilon. For this one total energy is epsilon. Then partition function Z is given by summation IGI e raised to minus beta EI, where beta is 1 upon kT and GI is the degeneracy. Since both the energy levels are non-degenerate, so value of GI is 1. So here we can expand this one as, so first one we have to consider energy 0, e raised to 0 plus e raised to minus beta, this is 2 epsilon, plus e raised to minus beta into epsilon, 1 plus e raised to minus 2 epsilon by kT plus e raised to minus epsilon by kT. Therefore option B is correct. Thanks for watching. Hope you like this video. Kindly subscribe and share this video and keep watching.